Hi, welcome to Mr. Hopkins's Honors Algebra 2 Mathematics class. Today we're going to take a look at section 11.1 Arithmetic Sequences. As you can see under the main ideas, we're going to start with finding some arithmetic means and how to use an arithmetic sequence. So those are the two main concepts we're going to look at today. We have 5 new vocab words. We're going to talk about a sequence, a term, an arithmetic sequence, a common difference, and arithmetic means. So before we get started, let's think of a real-life situation here where this is going to take place. So imagine you're a roofer who's nailing shingles onto a house. To nail these shingles on, they get overlapped one top of the other. Now, you would start with the bottom row and then shingle the next row above it and continue your way up. But if you look at the number of shingles on each row, first row contains 3 shingles. Second row contains 4 shingles. Third row contains 5 singles, so on and so forth. Looking at the number of shingles in each row, I get a list of numbers. This list of numbers, 3, 4, 5, 6, 7, 8, 9, can be called a sequence. A sequence simply is a list of numbers in a particular order. Each number in a sequence is called a term. So 3 would be a term, 4 would be a term, 5 would be a term, so on and so forth. Each individual term is then symbolized by the notation a sub 1 or a sub 2, so on and so forth. So the first term would be written a sub 1 equals 3. The second term is going to be written as a sub 2 equals 4. So on and so forth. Many sequences have patterns, such as the one above. The one above, you simply get the next number by adding 1 to the previous one. A sequence of this type is called an arithmetic sequence. And an arithmetic sequence is a sequence in which each term after the first is found by adding a constant, which is called the common difference. Now, let's start by first finding a few terms of a sequence. You've no doubt seen questions like this before. So the idea here is we're trying to find the next 4 terms of the arithmetic sequence, -8, -6, -4. Our goal is to try and find what is the common difference between terms. So if we simply look, how do we get from -8 to -6 is the question we're trying to answer. And for this scenario, I'm going to add 2. So then I look at the next 2, and I say, how do I get from -6 to -4? And again, I get there by adding 2. Well, the way I calculate the next 4 terms of that sequence is by adding 2 to what I already have. So since I'm currently at -4, adding another 2 puts me now at -2. Adding 2 to that term puts me at 0. Adding 2 to that term puts me at 2. And adding 2 one more time puts me at 4, which represents the next 4 terms of the arithmetic sequence. It is possible to develop a formula for each arithmetic sequence by using the first term a sub 1 and the common difference d. Here's our formula for the nth term of an arithmetic sequence. The nth term, denoted a sub n, of an arithmetic sequence with first term a sub 1 and common difference d is given by the following formula, where n is any positive integer. So a sub n equals a sub 1 plus n minus 1 quantity times d. This n is the same n as over here. So for instance, if I'm looking for the 20th term, the 20th term would be a sub 1, the first term, plus 20 minus 1, or 19, times the common difference. Let's put that to use. Here's a real-world example. The table below shows typical cost for a construction company to rent a crane for 1, 2, 3, or 4 months. Assuming that the arithmetic sequence continues, how much would it cost to rent the crane for 24 months? So, our first job, let's explore. And let's start with the chart. As I can see from the chart, it's listed by months and the cost. The months are pretty obvious, they go up by 1. The cost, I might have to do a little bit thinking. That's from 75 to 90,000, 90,000 to 105, 105 to 120. Looks like my common difference for the cost is simply 15,000. Now, I want to know how much will this be for 24 months. I have two options. I can continue my chart, I can continue counting, keep adding 15,000 to the cost until I finally get to 24 months. Now that is a little bit long and drawn out, so I need a faster way. The faster way is to use our equation from earlier. That equation, to refresh your memory, is given by a sub n equal to a sub 1 plus n minus 1 quantity times d. I already know d is 15,000. So now the question is, what are all the other variables? Well, a sub 1 represents the first term, and in this case, it represents the cost after month 1. So that would mean 75,000 has to represent a sub 1. N represents the number I'm looking for. I want to know how much is this going to cost me after 24 months. So the n becomes 24. And now I start to plug everything in. So a sub 24, or the 24th term, is equal to 75,000 plus 24 minus 1 times my common difference of 15,000. Now, if I solve this for a sub 24, this would be 24 minus 21, or 23, times 15,000 plus 75,000, and that would give me my final answer for a sub 24, or the cost after 24 months, which is 420,000. Alright, so let's now try to write an equation for the nth term of an arithmetic sequence. Now, I'm not given the task of finding a particular number term, like 24, but I do want to find the actual equation that I can use later on. This should just be a matter of, again, following the equation we just worked with plugging everything in. So the first thing, let's explore. Well, what's my first term? First term is negative 8. The other number that I need is the common difference of the sequence. Negative 8 to negative 6, negative 6 to negative 4. This is the same sequence we worked with earlier, which makes my common difference 2. Taking those two numbers, I can now find the nth term of this given sequence. So a sub n would equal a sub 1, negative 8, plus n minus 1 times d. Oops. Let's plug d in here. Times d, which is 2. Now, usually you're going to see this equation simplified a little bit. So we're going to take the 2, we're going to distribute it in, so that'll give me a 2n minus 2 minus 8, which means this is a 2n minus 10. This equation can now be used to find the nth term of any given sequence. So for instance, if I want the first term is found by plugging in 1 for n. 2 times 1 minus 10 is negative 8. If I want the 100th term, 100 goes in for n. 2 times 100 minus 10 is 190. Arithmetic means are what we're going to talk about next. Sometimes you're given two terms of a sequence, but they're not successive terms, meaning it's not one after the other. They're terms that are split. They're terms that are far apart. Well, the terms between any two non-successive terms of an arithmetic sequence are what we call the arithmetic means. The way you find the arithmetic means is by using the nth term of a sequence. Basically, use the equation that we just had to find out your common difference. Let's give it a try. Find the three arithmetic means between 21 and 45. So the idea here is I know 21 and 45 are two numbers of a sequence, but I do not know where they are in relation to each other. This is telling me there should be three numbers that fall between 21 and 45, hence the three arithmetic means. So what I do is I say, okay, if I know there are three numbers between 21 and 45, let's figure out what they are. And I split it up, 21 as my first number, blank, 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 45. There has to be three of these numbers in between. Now, what that tells me is the first number is 21, the fifth number is 45. From those two pieces of information, I'm able to set up my equation. So, I know the fifth term equals the first term plus n minus 1 times my common difference of d. Now, I plugged in the fifth term here. Keep in mind, I know what the fifth term is. So I can take this out, and I can write in its place 45. So this now says the fifth term can be found by 21, the first term, plus 5 minus 1 times d. If fifth term is 45, now I can simply solve for d. So I'll subtract the 21, which puts me at 24, equal to 4 times d, divide by 4, which puts my d as 6. Once I know the common difference, now all you need to do is start at the first term and continue to add that 6 until it matches up with this term. So if 21 is the first term, plus 6 means 27 has to be the second term, plus 6, 33 has to be the third term, plus 6, 39 has to be the fourth term, plus 6, 45 has to be the fifth term. What I'd like you to do before tomorrow is try these three problems to make sure we're okay, we're ready to go. Tomorrow during class we will practice this material in class in groups. So problem number 1, I would like you to write an equation for the nth term of an arithmetic sequence given -5, 3, 11, 19. The answers, by the way, are over here in yellow. Find the arithmetic means in each of the sequence, 82, 18. Looking for the three arithmetic means. And again, answers over here in yellow. And finally, one more problem. See if you can answer those three questions. And tomorrow, at the start of class, please bring in any questions that you've had from today's lesson, any questions that you've had with these three problems, and we'll continue to work on this section during class time. Thanks, and we'll see you tomorrow.